Today is a lesson about logistic functions. Logistic functions are written in the format of P of t is equal to L, which is a constant, over 1 plus E, which is a constant that has a set value, to the power of negative kt. K is again a constant. The independent variable here is t. So, what do graphs like this look like? Well, firstly, you notice that they have this E thing here. E is a constant E is a constant which is in between 2 and 3. And essentially, if we try and plot this graph, let's look at an example. P of t is equal to L, right? So L over 1 plus e to the power of negative kt. So what happens, as you can see, what happens when we change L? If we increase L, this graph vertically increases, it goes up. And if you increase K, the graph gets closer to the y-axis, so it's steeper. So what are the characteristics of this graph? So firstly, you know that this graph seems to have an upper limit, because right now over here, if I gave you this graph, if I cut this off and pasted it somewhere so that you could see it, you'd probably think this is a straight line, a really boring straight line. And this proves how the graph has an upper limit, or it has an approximate upper limit. Now, what's this upper limit? Well, this upper limit is L, because you see, as L is up around 6.6, this graph, L is 6.6, this graph gets to 6.6 also, and it stops growing. So the limit is L. If we decrease L, the limit decreases. If we increase L, the limit increases. Now what about K? What does K do? K decides how fast or slow this graph reaches its limit. If you increase K, you're increasing the steepness of this graph, so you're basically increasing the speed that this graph is reaching its limit. So this graph can be split into a few parts. Firstly is this part where in the negative x, where this graph isn't growing, it just sticks to 0. And then it has exponential growth at some rate. So at some rate, starting from x equals negative something, it has exponential growth. So this is always the exponential growth. And then, after some exponential growth, it reaches its top limit and it goes back to the horizontal line that is really boring. So there is horizontal, exponential, and horizontal. The K decides its exponential growth. It decides how the growth rate of this exponential growth graph. L decides the upper limit of the exponential growth. So that's all, and now let's talk about why L is the upper limit. Because you don't just go like, I'm going to define this function, I'm going to define L as the upper limit, and then you don't just go like, when I input into the graphing calculator, I expect the graph to have L as the upper limit. You want to know why and what makes the graphing calculator make L the upper limit. Well, here's the case. So we know that K is a constant. So let's say K is 5 to make stuff easier. And then let's say L is 10. Okay, so as you can see, the upper limit is 10. And so why is that? Because so essentially what happens is when you input t, so firstly let's look at this e thing. E to the power of negative 5 times t. So what's e to the power of negative 5? That's just 1 over e to the power of 5t. Right? So these two are equal. So as t increases, this whole fraction actually decreases. So if t increases, e to the power of negative 5t decreases. So what happens when that decreases? It means that 1 plus e to the power of negative 5t decreases. And as you can see, as we increase t by a lot, this fraction is really close to 0, but it never is actually 0. But it's really close to 0. So when it's really close to 0, this thing is actually really close to 1. So what happens when L, our upper limit, or 10, is divided by 1? Well, we get L, or we get 10, right? So essentially, as this value decreases, as this value decreases, L over 1 plus e to the power of negative kt actually increases. So, but it has a boundary of increasing, because e to the power of negative kt can never be below 0. So it has a boundary of increasing. And the largest approximation for this increase is that this whole bottom part is equal to 1. So if this is 1, then L over 1 is just L, so the graph reaches its limit. And no matter how much you increase t, this number is so close to 1 that it's just approximated by 1 with the calculator. So L over 1 is just L, so there's a limit over here, and it never grows again. Okay, so that's all for today.